Hi, today we're going to learn how to solve by factoring. So first, we need to review FOIL. If we have A plus B quantity times C plus D quantity, if we want to multiply these two together, we have to remember FOIL, which is first A times C out plus A times D inside, which is B C last. So B, D. So if we want to factor a polynomial of degree 2, we need to consider ax plus b times cx plus d. If we factor this, we get acx squared plus out. That was the first. Out is adx. In is plus bcx. Last is plus bd. So, looking at this, acx squared plus ad plus bc, that quantity, times x plus bd. But in English, what we need to do is we need to find the form ax squared plus bx plus c. I'm not talking about this here. This is the general form of our parabola. So if we look at this, we want to find two numbers which multiply to get c and add to get b. So with this in mind, let's go to our problem here to solve for the zeros of this equation. And so before we begin factoring, we have to consider, can we factor out any constant out of this? Yes, because we have 2, 14, and 24, which are all divisible by 2. So, f of x equals 2 times the quantity x squared plus 7x plus 12. Now we have a simpler expression to factor. So, can you think of any two numbers that multiply to get 12 but add to get 7? Pause the video right now. So the answer is 2 times, well first, the answer is 4 times 3, multiply to get 12 and add to get 7. So we know that if we go x plus 4 times x plus 3, if we FOIL this out, we'll get x squared plus out, which is 3x, plus in, which is 4x plus 12, which is x squared plus 7x plus 12. So we know we did it right. We can always check our work when we factor by just multiplying everything out again. So this will be our factored of f of x. So if we graph this, we can see that if we plug in -4 here, we get 0 for y. And if we plug in -3 here, we get 0. So we know that -3 and -4 are both zeros. And we know that since a is positive, it goes up. So, and we know that our vertex will be -14 over 2a, which is 4, about -3.5. But we can also see this because we just take the average of the two x0 points. So our axis of symmetry is going to be right here. And solving for our y value of our vertex, we get f of negative 7 halves equals 2. We get negative 0.5. So we know, kind of invaded the graph here, that negative 3.5, negative 0.5 is our vertex, so we know that our parabola goes like that. And we know that our solutions for 0 equals 2 times the quantity x plus 4 times the quantity x plus 3, aka this. We know that the solutions for this, when we want 0, are negative 4, negative 3. Those are our solutions. As another example, we have this expression that we want to factor. So we ask ourselves, is there any common term out of these 3 terms that we can factor out first? So we can see that these coefficients are all a multiple of 4, and we have z squared on each term. So we can factor out 4z squared times the quantity 2x squared minus x minus 3. So can we factor this? Yes, because we have 4z squared times the quantity 2x minus 3 times the quantity x plus 1. And we can see if we FOIL this, just this part out, we get 2x squared plus 2x minus 3x, which if you add those together, you get negative 1x. And then negative 3 times 1 is negative 3. So this is our factored expression. For another example, if we want to factor this, if we look at just these 2 terms here, we see that they each have a factor of 8, and they each have an x. So we can go 8x times the quantity 4y plus 5b. Here, we see that these terms both have a negative 3 and an a. So we can factor out negative 3a, and then of course we have times the quantity 4y plus, because we don't forget to undistribute the negative, 5b. So if we look at this, we see something kind of cool, because both of these terms, if we consider this a term and this a term, they both have a 4y plus 5b. And we can, if we consider the 4y plus 5b to be, say, c, if we set c equals 4y plus 5b, we can see clearer that we have 8xc minus 3ac. And then we can factor this out. So we get 8x minus 3a times c. In this case, though, c is 4y plus 5b. So this would be our factorization. And we can check this by distributing through, back again with FOIL. So we have 32xy, this first. Out is 40xb. In is negative 12ay. And then last would be negative 15ab. And so if we look, we can see that we have the same thing, which means that we factored it correctly.